Section 12.3 is about inscribed angles. So the first thing that I'm showing you here is that you have a diagram. An angle B is an inscribed angle, meaning it's inside of something else. Angle D is a central angle because it's starting at the center of the circle. And then angle A or arc AC is the arc that they both intercept. So what we do is we can use this diagram to come up with a theorem, and that's the inscribed angle theorem. It states that the measure of an inscribed angle, which would be angle B, is going to be half of the central angle that intercepts the same arc. So notice that these two angles intersect at the same spots. That's what they're talking about in terms of you can use this theorem. So let's look at an example here. So my first example asks me to find the measure of angle T, and it gives me angle S, that's 38 degrees. So this angle that is inscribed will be half of my central angle, so meaning the one that's at the center. So remembering that this guy touching the circle has to be half of this guy, so it has to be smaller. So I said angle S has to be half of angle T. Then I put in 38 for angle S, and then you have a couple different ways you can go about finding it. One way is you can just divide both sides by a half, or you can just multiply 38 by 2, so going either route. So I either divide by half, or I'm going to take 38 and multiply by 2, and I get 76. So my central angle at angle T would be 76. Alright, let's take a look at another example here. So now it's asking me to find what EFG is, which is this angle back here. So before I can get started, I need to find this angle, the central angle, being that those are the spots that they intercept with. So what I did was I took 360, since I have a circle around the center, and I subtracted 93 and 150 to find this remaining angle. And I found that H has to be 117, so that's why I wrote that in there. Now I know that this central angle is going to be, I'm going to have to do half of it to find what that EFG is. So I'm going to do half of 117, which is why you're going to multiply. And then I find that this angle back here where it's inscribed would be the 58.5. So when you get these other kind of problems like this, if they're in the center, you're going to want to find that remaining angle, and then you're going to remember the inscribed one has to be smaller, so that's why I'm taking half of this 117. Okay, taking a look at another example here. They give you an angle at the central angle, which is J, so that's at 63. But what they're wanting you to find is GHI, which is this angle here. Now, what I noticed was the fact that since I'm at a central angle, these two rays, if you will be congruent to each other because they're both radius. So since they both are radii, I should say, they're going to be congruent to each other, which means I have an isosceles triangle. So what you can do is take 180 and subtract away the one angle that you know, which is 63, and then take that remaining amount and divide it by 2, since I have two angles that would end up being congruent to each other, and I would get my angle measurement. So I found that it would be 58.5. So again, noticing what they give you the central angle, they end up giving you a triangle, and since these are radii, they end up being congruent, which is why it's an isosceles triangle, which means those base angles have to be the same. So that's why I said that angle GHI has to be 58.5 degrees. Okay, so I just wanted to run through those examples with you, and then there's a couple more where they give you some expressions versus just the numbers. So in this case, they're asking you to find angle IHJ, which is the inscribed angle, and they're giving you the central angle. So you're still going to use that theorem. So I'm going to use the fact that angle H has to be half of angle K, and then I plugged in the expressions that I know. So I know that 3x has to be what angle H is, and they told me angle K is the 14x minus 88. So now we're just using some algebra skills to solve it. So I would distribute this 1/2 across here, so I would multiply through. So I would get 7x and then negative 44. And then I'm going to want to combine my like terms, so I'm going to minus 7x to the other side, so that's how I'm going to get negative 4x on the left side, and then drop down my negative 44, and then I'm going to divide by negative 4, so I get x to be 11. Now pay attention, because IXL will switch between asking you to find what x is and maybe finding the angle. So in this case, they're wanting the angle. So angle IHJ had the expression 3 times x. I just found that x was 11, so I'm going to plug it in there, and I find that the angle measurement is 33. Okay, last example here. We have more inscribed angles. The piece that you need to know when you have these inscribed angles like this, if they look kind of like a time clock, if you will, so you should be finding that these two angles are going to end up being congruent to each other. So what I can do is just set them equal to each other and solve it. So I decided to minus x from both sides, so I get 1x on the right hand side, and then I decided to add 97 to the left side, so I got 68 equaling 1x, and if you want to divide by 1 you can. Again, checking to make sure, am I finding x or am I finding the angle? In this case, I'm finding the angle, E. E has the expression x minus 29, so I'm putting 68 in for the x spot and then solving, so I get 39 degrees. So I didn't give you any got it questions on this because of the fact that I wanted to make sure that you had enough all the way through to get you the score that you may want. So you can always run through, obviously, those practice when you're doing the IXL. So that's why I didn't give you any got it questions here. But if you have questions, let me know.